Good morning, this is Mr. Morales, and I'm going to explain to you how do you do exponential growth and decay word problems. So first, we begin on page 105 with our notes. And what we have here is the exponential, I didn't mean to get so far ahead of myself, the exponential growth and decay general formula. So from the very top, it tells us that you can model the growth or decay by a constant percent of increase or decrease with the following formula. And it's read as A of t equals A times 1 plus or minus r to the t power. So let's break down each part. I color-coded it because I'm going to show you how each part relates to the word problems as when we get to them. So in the very beginning, A of t, this stands for your total amount. This is how much you end up with after you've increased or decreased based on your scenario in the word problem. Little a stands for the initial amount, how much you had in the very beginning or when your word problem takes place in the very beginning or initially. Next we have plus or minus. Now plus would be if you have an increase and minus would be if you have a decrease. You can only use one or the other. You can't use both at the same time, obviously. And depending on the word problem, you'll determine whether it's plus or minus. R stands for the rate of increase or decrease. It's given to you as a percent most of the time. And when it's given to you as a percent, you must divide it by 100 to turn it into a pure decimal in order to plug it into the equation. And t is your time interval, usually years, it could be days, weeks, depending on what, of course, your word problem gives you. So pay attention to, as we read the stories, you see the color-coded pieces, they all correlate to each part of this equation. So here we go. Here we have number one. The Greens bought a condominium for $83,000. Assume that its value will appreciate 6% per year. How much will the condominium be worth in 5 years? So in order to use this equation, you need three general parts. You need your initial amount. You need to determine by reading the story if you're going to have increase or decrease, which is just a sign difference. That's pretty obvious usually. R, you need to determine your rate and the amount of time. So here we have all the pieces given to us. We have our initial amount of $83,000. We have our rate of 6%, and we have the time for 5 years. So I go ahead and I wrote everything out on the left-hand side, all my amounts without any units. And I went ahead and I plugged in, I wrote the formula as the first step. So our amount that we're going to get total is equal to A times 1 plus our rate because we have appreciate. Appreciate means that we're going to be increasing or gaining, plus r to the t power. So I plugged in all my numbers, my little a, my rate as a pure decimal, and my time, 5 in years. And I get the answer of the amount total I'm going to pay for 5 years will be equal to $111,073. That's how much this condominium will appreciate in 5 years, starting off at $83,000 to here. That's a good appreciation, not too bad. Our next example over here, number 2. Now it tells us the value of a truck bought new for $28,000 decreases at 9.5% each year. How much will the truck be worth in 8 years? So the same thing here. Identified my initial amount, my rate, and my time. I took the rate, of course, divided by 100, just like I did above, got the pure decimal. And since I have decreasing, I'm going to use the subtraction sign in my formula for exponential decrease. So I have subtraction. I have all my parts plugged in. Just plug into the calculator. But make sure when you have your final answer, you have units, because you want to know what you're measuring, what your final answer is going to be counting. So the amount that my truck will be worth after 8 years is equal to $12,599.30. Of course, this would be approximate, but that's pretty much how much it decreased or depreciated, if you want to use another word, similar to the one we used above. And there's your total. Number 3, this one, it has a special scenario. Here we have the Mendelssohn Stradivarius violin was estimated to be worth approximately $1,700,000, and that was back in 1990. The violin is expected to increase in value by approximately 7.5% each year. Estimate the value of the violin in the year 2010. So here we have a couple of components. We have our A, our initial amount, so we have the $1,700,000. We have our rate here, the 7.5% divided by 100 gives us 0.075. And then we have our time. From 2010, which is when we take the final measurement, from the beginning initial time of 1990, we have a difference of 20 years. So that's going to be what our t is. So I went ahead and I plugged in all these numbers into our calculator, and I'm going to show you what the calculator gives us so you won't be surprised if you get an answer like this. So let me go ahead and go back to what I was looking at right now on my calculator. Here we go. So our first example, when I plugged it into the calculator, it gives us an answer in scientific notation, and you can tell because it has that E at the end of it. That E6 means something very specific. It means you're going to take your decimal and move it 6 places in the positive or right direction. So that's exactly what I did in my notes here. We have the 7 point and all those numbers that came after it. I had to move it 6 times to the right. 1, 2, 3, 4, 5. If you have to move it and there's no numbers available, you fill in those gaps with zeros. And now we have our final answer of the violin will be worth $7,221,350. Actually, it was worth that approximately back in the year 2010. So it's obviously gone up because now it's 2019 as the recording of this video. And I'm sure it's worth more. You can calculate that if you're curious to figure out how much it's worth by now. And our final example for today's notes that I'm going to show you has to do with a guitar. So it says, Tony purchased a rare 1959 Gibson Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. Use a graph to find when the value of the guitar will be $60,000. Now we could graph it, and I'm going to kind of go ahead and skip that because I'd rather show you a faster way to get the answer. So let's write down what we know. Our initial amount is $12,000. Our rate is 14%, which converts to 0.14, but the time is the thing we do not know. We want to know when our total amount of this guitar will be worth $60,000. So I go ahead and I take my equation and I boxed in the total amount at 60,000 and correlated it with the A of T over here in our equation so you know where we're going to plug it in. So in this case, we're given everything but the time. So I plugged in $60,000. That's what we want it to equal. We know it began initially with worth $12,000 back in, 2000. We know that it increased in value by 0.14% or 1.14 when you add them together, but we don't know the T, the time. So I went ahead and solved with our calculator, and I even used T as my variable, and when I did that, I went ahead and I got this answer, 12.